.NET controls, how to work with .NET objects within PxPlus, and how to handle events. And there's going to be examples all throughout when I'm talking about how it all works. But at the end, we're going to actually finish off with sort of two more real world examples that sort of tie everything together as well. So our goal here with the .NET interface and with this presentation is to introduce you to the sort of power of .NET and how you can leverage it in your application to modernize it or to take advantage of new features. So what is .NET? Well, .NET is a free open source modern application framework. It is widely used throughout the industry. It is developed by Microsoft. It started off not open source, but over the years has moved to a more open source platform. For our purposes, we can see it as a rich set of built-in sort of existing code libraries. These code libraries can do anything from be ready-made UI components, or they could be components that allow you to not have to write your own code to do certain things like cryptography, XML, JSON parsing, database access. And the UI components are often like industry standard, they're advanced, and these include things like modern grids, the list views. It involves, they include things like charts, diagrams, 3D visualizations, specialized controls for grids, maps, displays. There is thousands upon thousands of .NET controls out there, over 300,000. And .NET is sort of a way, what it is built on top of. And if we can work with .NET, we can take advantage of all these libraries. So that's what we wanted to do. So in PxPlus 2025, we built a fast pathway between PxPlus and .NET. So this means within PxPlus, you can actually access and use those .NET libraries. If you're wanting to use a UI control, it's going to be the type of .NET library we support are called the WinForms UI controls. There are several UI libraries within Windows, and the ones we support is called WinForms, but all the non-UI objects would be compatible. Our .NET interface works under Windows and Windex from a Windows client. Since this is .NET and it's based on a third-party application framework, the .NET desktop runtime does need to be installed for you to be able to use the .NET interface. So this means that in your own applications installer, you'll need to check to see if the .NET runtime is installed, and if not, install it. Pretty much all the modern installers support this because it's such a common thing for applications to need to do. You want to make sure, of course, if you're using 64-bit PxPlus, that you install the 64-bit version of the .NET desktop runtime, and they call that x64. And if you're using 32-bit PxPlus, you want to use the x86 runtime, which is the 32-bit one. Our goal with our interface is we wanted it to be sort of allow you to use it as many ways as possible and for it to be fast. Because we do have and have had for a long time a COM interface based on some older Windows interoperability layers. But it always suffered from, due to sort of how that technology was built, speed constraints and how much resources it can use. We don't have those constraints with .NET. So there are two ways you can use it within PxPlus. If you're using Nomads, you can, from the Nomads panel designer, you can create a .NET control and you can access its properties. You can also do everything from a PxPlus program. So if you're non-Nomads, this all can still work, and you can do everything from code. So we're going to start off by talking about how to create a .NET control. And we're going to start on the Nomad side. So from the Nomads designer toolbar, you're going to click the external controls button. This button used to be called the COM control, We renamed it external control since now it's COM and .NET. Actually, before we added .NET, it was also the embedded browser control, which isn't technically COM. And we had a few other controls there that were not COM. So calling it the external control makes a lot more sense. So you click on that, you draw a rectangle on the screen where you want to put it, and then in the properties window that will come up, you select the .NET control from the query. Click query button, select the control you want, which is .NET. And then this side of the screen will give you 3 input fields. The first being DLL name, second object name, third arguments. Now the DLL name, this is going to be either the path and like the full path name to the DLL where your .NET control is defined, or if you're using one of the many system .NET objects that come installed with the .NET framework. These are found in the GAC or Global Assembly Cache, but effectively, from a programmer's perspective, if you go on to the Microsoft documentation, there's a big list of all the system objects, and it tells you what that DLL name is for you to access it. The next part is going to be the object name. This includes the namespace of the object and the object name itself. Once again, you'll find all this information in the documentation for the object you want to use. In our example, we're going to go through here. We're using System Windows Forms for the DLL name and System Windows Forms button for the object name. So this is sort of the default .NET button that comes with the .NET framework. And that's what we're creating. We don't actually specify any of the arguments. We don't need to pass it anything in when we're creating the button. Some other things to note here is .NET is case sensitive. Someone could create a .NET object called button, all lowercase, and someone could create one all uppercase, and they could be separate objects. So make sure you pay attention to the case when specifying the object name, as that can have an effect. Now, hopefully no one does silly things like that with the all lowercase and uppercase, because that can lead to confusing times. But once you fill this in, we're going to click OK. And then if we test our panel, we're going to now just have an empty white button on our screen. But this is the .NET button. And our next step is we need to sort of work with our button object to customize it in the way we want. But if we want to do the same thing from code, we use the def object directive. So this is just like the def object directive if you've ever used COM or instantiate start browser from code. The first bit here, extid, this is just going to be store your handle to the object. If this is a graphical .NET object, you specify the coordinates and the size you want your it to be on the screen. Object def, this is going to be a string that starts with square bracket .NET. Close square bracket, and then followed by the DLL name, comma, object name. Now, this is the same as we just talked about with on the Nomad side, the DLL name being the path or the name of the system DLL. Object name is also going to be your namespace plus your object name, and this is case sensitive. Now, if you're using Windex, you will want to include a square bracket WX square bracket or square bracket LCL square bracket in front of the .NET in order to tell the system that this code actually runs on the Windows client. And finally, if you are passing in arguments to while building the .NET object, this is where you specify your numeric string variables or literals that you need to pass in. So an example of this code is pretty simple. We're just going to use the same DLL name, System Windows Forms, and same object name as we used in Nomads, the button, and then we're going to do a def object here. And here you can see the LCL, so this will work on Windex or local, and .NET, and then we're passing in our name and object. And up in the right corner here, you see we also now have a blank button. So now you have, whether you use nomads or program, you have your object. How do you work with it? Well, that's sort of going to be the bulk of our presentation today, because there's lots of ways to sort of work with our objects and lots of things you have to consider. So we're going to start with the simpler side. Is if you're using nomads, if you open up the external control properties for your .NET object and you select properties, you are going to get a tree view, and this tree view will show you all your objects, child objects, if it has any. And they will be listed here. And then on this grid here, this is actually going to show you all the properties and methods defined by your .NET object. Now, if I click on one of these child objects, this will repopulate with the properties and methods for that child object. If you've used COM or Start Browser, this is the same interface effectively. So if we look at that grid a little bit, what the information you have here is you've got the name of your property or method, and then you've got the type, whether it's a numeric variable, a string variable, whether it's an object type, something that's not a numeric or string, or whether it's a method. Then if it's currently has a default value or is set, you can see what the current value is. And then you've got your expression, value expression. These are used to either define numeric literal or a string literal, or if you want to use some code, you select expression, and then you can have some code in here, like specifying a variable name, which will be used to set that property. In our example here for our button, we're going to actually scroll down to the text property and set it to the word save. So this is going to be a save button. Some other things to note, if the property you are setting happens to be a object type property, so it's another, so since we're in a .NET object, it would be another .NET object that is either being set or returned from that property. We have a special extended property called PxHandle$, which we use to set that. And I'll talk more about that later, and there'll be examples. But this interface can, as you can see here, we are setting a string property using this grid, but we could also invoke a method if that method accepts one string argument. Then you can actually use this grid as well. If it doesn't accept an argument or accepts more than one argument, you need to do it from code. So if we test that panel, we've got the same button we saw before, but now we've got the word save. So we're getting somewhere now. So if you need another way you can work with your objects, obviously, is through code. So you can actually use your pre-display, your post-display sort of logic entry points on your header panel, or the post-display logic entry point for your .NET control. And then you can specify like a default program and a label, and that will allow you to execute that code. And that code could do lots of things like define other .NET objects, which you used to interact with your .NET object. And we'll see some examples of that too. What that code would look like, it's going to look very similar to if you've worked with any other object in PxPlus. Everything is done through the apostrophe operator. And like other PxPlus objects, if you print your handle of your object, apostrophe asterisk, you get a list of all the properties and methods for your object. And setting properties works just like any other object. You say tick your name of your property, and then you can assign it. And methods are tick the name of your method, and then square bracket. It's useful to know that within .NET, properties and method names are case insensitive. .NET itself is case sensitive, as we mentioned a bit earlier. But once we are working with an existing .NET object, we can assume and make it case insensitive unless you tell us you need it to not be case sensitive using the PBX case sensitive property. So if you set this to 1, then the properties and method names will be case sensitive. And you'd only really need to do this if someone defined a object with a property name or method name that is the same as another property name or method name with a different case. So by default, this is off, and it's going to be case insensitive. So our example here, we are doing net button is the .NET object we did the def object for earlier. So we do tick, and our property we want to set is text, and it's a string property. So we have $, and we set save. And then up here, you can see we've got our button, which now has the word save in it. All pretty straightforward. Now, .NET objects may actually have properties or methods defined that use PxPlus reserved words in them. Now, PxPlus reserved words are usually 3-letter system variable names or system function names like day or log. So if you were working with a .NET object that has a log method, for example, if you just tried to write that out in PxPlus code as extid tick log, you would get an error because log is a system function. In order to avoid this, you can prefix any .NET property or method with not PBX underscore, and then the name of the method. So in this case, our example is we want to access the day property. So we say not PBX underscore day, and then this avoids the collision with our system variable. Now, if when working with .NET code, if you get an error and want to find out more information about it, you can check the message -1. That's where we return the error information. And like all PxPlus objects, when you are done with an object, you can use drop or delete object directive to free up the resources and memory and the CTL handles. Now, when working with .NET, lots of things are objects. So a lot of things that will get returned to you by your .NET object, maybe another .NET object type. It's important that as you're working with things, you generally make sure that you give things handles so you can clean them up later using drop or delete. And we'll show that in examples too. Now, we have added a bunch of extended properties to every .NET object that's loaded into PxPlus. You'll be familiar with this if you've used COM or Start Browser. The first one we've already talked about, PBX case sensitive. This allows you to tell PxPlus whether you want those properties and methods to be case sensitive or not. It defaults to case insensitive. The next set here, PBX call line, calls, lines, left, top, width, height, all allow you to control the position and size of the .NET control on your PxPlus screen. Then we've got PBX events. There's actually 2 properties here, the numeric variable of this and the string variable. The numeric version will actually return you a handle to an object if you are subscribing to events via an object. And I'll talk about that more later. And the string version of that will return you a list of all events of the object and which ones you subscribe to and which ones you haven't subscribed to. But that will only have a value in it if you are subscribing to events via an object. The PBX form extended property allows you to access the win form that the .NET control is drawn into. Whenever you draw a .NET control on the PxPlus screen, effectively it draws a win form and then draws the object in it. And if you need to access that win form to change its size or background color or things like that, you have access to it using this property. And PBX handle $, I mentioned very briefly, it is how you pass in .NET objects into a .NET object. So we need to talk a bit more about how sort of .NET works and how we handle that on the PxPlus side. It's important to keep in mind that everything in .NET is an object. Even strings and numbers and booleans are objects on the .NET side. But in order to make it easy to work with from PxPlus, we automatically convert numbers to a normal PxPlus number in our code. So while dealing with .NET and you need to pass in a number, you can just pass in a numeric literal and numeric variable. And it handles the conversion for you into the correct .NET numeric type. And vice versa. If you're getting data back from a .NET object, it's just going to be treated as a normal PxPlus number. And this works for numbers with decimals or just plain integer numbers. Same with strings. The conversion is automatic. Now I've listed here the different sort of .NET types that we convert to. So different size of integers and unsigned integers, and double for numeric. For strings, like the string object itself, but you can also have a single char object or an array of chars, a byte, an array of bytes, signed byte or array of signed bytes. And booleans are handled and converted either to a 0 or a 1. 0 for false, 1 for true. Now, if you are dealing with something that is not one of those types, we just talked about those strings, numbers, or booleans, it is going to be kept as an object. So that means if you were reading the value of a property and it is not one of those types, you are going to get back into PxPlus a handle for that object. And then we'll be able to work with that object just like any other PxPlus object. Now going the other way, if you need to pass in a .NET object into a .NET object, that's where we use this PVX handle $. And this is true whether you are passing in an object as part of one of the constructor arguments, whether you are assigning it via a property or you're passing in as an argument for a method. It's important to note when you're doing an assignment. Now, normally an object is a numeric variable, and the contents of that numeric variable is just the handle to the object. But when you are assigning for a .NET object, you want to actually add a $sign to the end of your left side of the assignment, like down here, because we are using the PVX handle $extended property, which is a string type. And so you need to make sure the other side is a string type. And this is just a way we could support in our existing syntax, a way to tell the system that this is a .NET object assignment, so it can handle it as such. Now, it's a bit simpler if you're passing it as an argument. You don't have that issue. You just use tick PVX handle $, and there's no other side you have to worry about there. Okay, so let's do a simple example here. And in this example, we are defining a .NET object called color. This is a system object called, in the namespace, system drawing, and the system DLL it's found in is system.drawing. So we create an empty color object. But that color object itself doesn't have any value to it. There's no color set yet. But I want to use a color with a name. So I can use the property lemon chiffon that this object provides me. And what this property does, it returns a color object with the RGB values all set to the right values to be the color lemon chiffon. So I'm going to save a handle to that new object, lemon chiffon, and then I'm going to say net button asterisk back color $, equals lemon chiffon asterisk PVX handle $. So color itself isn't just a string or a number or a Boolean, so that means it itself is a .NET object, and so I'm passing it in using PVX handle $, and that's why we use that syntax here. But after I do that, I can clean up my lemon chiffon object and the original color object. And the result of that here is now my button has color. Another thing to keep in mind with .NET objects is object type you'll often encounter is called an enumerator. An enumerator is just a variable that is allowed to be a preset list of values, and those values generally have a name. There is sort of two types of enumerators, one where the value of that variable could just be one of those, effectively one of those names. So it could be one of those values, but you also have a flag enumerator where you can define the value of that variable to be multiple values, multiple of those named values. Now, with everything in .NET is an object, and the properties of the object will be all those names. Each of those names will be one of the properties. There'll also be a property that is value underscore underscore, and this is going to be the physical sort of numeric value that represents that name or the sum of the names that have been defined. Now, if you want to, from PxPlus, if you want to set an enumerator, that is a flag enumerator, so you want to set it to multiple values, you would say, you would set the value equals equal, value underscore underscore property, and you would set it to the sum of the values of the different named actual values you want to set. It's going to be easier to see in the actual demo. It's actually pretty straightforward. There's also a toString method, which will return you a string that has the current value's name. So you can easily sort of see what's set. So an example, we're going to use the font style object. Now the font style object is a flag enumerator. So if I do print font style asterisk apostrophe, apostrophe asterisk, the output is going to be all the properties and methods of my object. In blue here, I've got the name values that are defined for this enumerator. So this is pretty familiar. If you've ever set fonts, we got bold, strikeout, underline, italic, regular. And then we've got the value underscore underscore here. So if I wanted to define a font style that is bold and underlined, I just say font style tick value underscore underscore, and then I assign that the value of bold plus the value of underline. So now if I use toString to see what my current setting is, you can see it says bold underline. So I can now use that font style I've just defined, and I can pass it in to a font object when I define a .NET font object. So I'm defining a font object here. The font name I want to use is Verdana. Font size is 12, and then I'm passing in my font style using tick PxHandle$, because an enumerator is a .NET object, so I need to use PxHandle. Then, now if I want to use that font on my button, I can say net button tick font$ equals font tick PxHandle$. And now my button up here is using Verdana 12 bold underline. And then I can drop font style at this point because I'm done with that. Okay, so a few more things to keep in mind. That there are sort of different types of objects. A common type of object you'll encounter is a value type object. With value type objects, each time you if it's a property, for example, each time you read that property, you are going to get a new copy of that object. And then you would be working on a copy of that object. So making changes to that would not affect the parent object because you had a copy. When you assign that value type object, it will actually make a copy of what you're assigning it to and make it part of the parent object. So it's very similar to in other languages in PxPlus, how numbers and strings and not objects are dealt with. It's always copies. But it's important to know sort of, and when reading documentation for a .NET object you're trying to use, if it says it's a value type object, then you know you can't just say my object tick child object tick change like value equals 2, because that may not actually change anything in your parent object. What you need to do is you need to save a version of, you need to save a copy, make your change, and then assign it back. And make sure to drop and delete that object once you're done with it. Since it's just a copy, if you don't delete it, it will just keep using up memory. Enumerators are an example of value type objects in .NET. So we can see another example of this. In our button object, there is a property called size. And this is known as a size object. It is a value type object. So if I wanted to change the size, I couldn't say net button tick size tick width equals 64. Nothing would actually change on my button because what I've done is I've created a new size object and I've changed its width. And then I haven't even stored a handle to that new size, so I then couldn't do anything with it. After this executed, the system would automatically clean up that size object. So effectively nothing would happen. What we do instead is we say net button tick size, and we save a handle to our size object. We set its width to 64, and then back in our button object, we set the size property to our new size button, or our new size object, using passing it in as with PBX handle dollar because it is an object. Once we do that, we can actually get rid of our button size object since it's now copied into here and no longer is being used. So the end result of this would be is we have actually told .NET itself to make the object smaller, but in PxPlus, we have still defined the object to be this size. So now we have a gray background. And that gray background you see is actually the win form that we created automatically for you when you created your .NET control. But you can actually control the win form using the PBX form extended property. So I could then say net button tick PBX form tick size and get a copy of that size object. I could set that to 64. And then I could say net button tick PBX form tick size dollar equals our new object. And then I would get rid of that gray background because I've now made the form the same size as my .NET button. And then I could clean up the no longer needed size object. And that also gives you an example of how you could work with the form on the actual win form behind a .NET object as well. So the other type of object is the non-value object. And in this case, you can think of this as sort of a child object. So usually when the parent is created, it will allocate these child objects itself. But it also means that if you then modify those child objects directly, you actually change the parent itself. You don't need to make a copy. And every time you access that child object, you're getting a handle to the same object. It's not creating copies. An example of this, I'm going to use the data table system object. And it has a property called columns, which is an object that represents a list of columns. And with data table, since this is actually just a child object, each time I say data table tick columns, PxPlus is going to get the same handle back to it. And so for short, I can just say data table tick columns tick add, and then I can directly affect data table by adding a new column. I don't need to create a copy and reassign it back. There is another type of object, or in this case, it's not even object. It's called a static class. This behaves just like an object, and you use it just like an object. But static classes, they don't actually have any properties that can that aren't constant. Usually a static class is a list of constants and methods that act on whatever arguments you pass into it. An example of this is the system math object. It provides you a bunch of named mathematical constants, which you can access and then get the value of. It also provides a bunch of functions, like mathematical functions like arccos, that allow you to do math. But it itself doesn't have any state. But these work just like you would work with any other object in PxPlus. Just be aware that, yeah, it's a static class. Okay, so now we can move on to talking about events. Now, a big part of working with UI controls is dealing with events, and a lot of your logic will happen when events happen. So from the Nomad side, you can use you open up external control properties and go to the properties tab. And then the grid on the bottom here, this actually will be auto-populated with your .NET controls events. So if we look at the different columns here, we've got the name of the event, and then we've got what we're going to do with that event. By default, all of them will be ignore, which means we do nothing with the event. We're not subscribing to it. But you've got 4 options. You can link, so when this event happens, you can tell it to invoke a panel. You can perform, which will perform a program, and that program can be just a program name or a program name and label. You can call a subprogram, also program name and label can be specified there, or you can execute. You can actually specify PxPlus code directly and separate statements via semicolons right in here. So you would use that if you were trying to do something really simple that was like 1 or 2 lines of code. Now, if you are subscribing to events in this way, it has the benefit of being very easy and done all through the Nomads interface, but it doesn't allow you to take advantage of event arguments provided by .NET. So whenever a .NET object triggers a event, it actually provides some event arguments, and you can only access those if you subscribe to events using a event handling object, which I'll go over later. So if you want to do the same thing as we just did from Nomads in code, this can be done using CTL events and the onEvent directive. So from code, if I want to subscribe to an event, I could say onEvent, give it the name of the event, give it the handle to my .NET object, pre-input, and then the CTL I want to trigger when that event happens. And unsubscribing is similar, you just with the word remove there. So a very simple example of this, I'm going to I'm going to define a click CTL as 42, and then I'm going to do on event click from net button, pre-input, click CTL. And then I'm going to set up a CTL listener for CTL 42 and make it run the code at label click. And all this code will do is bring up a message box. And if we look at what I did in Nomads, it's the same thing. We're subscribing to the click event and just running a message box, just as a very simple example. So the other way to subscribe to events is using a event handler object. This is also done using the onEvent directive. In this case, onEvent from the handle to your .NET object, process, and then a handle to an event handler object. And to unsubscribe, you just say process 0. So the event handler object would be an object you would create, which would have a method for each of the events you want to subscribe to. And I'll show an example of that soon. If you subscribe to events this way, the extended property PVX events will actually display the handle to your event handler object. And PVX events extended property will give you a list of event names, and they'll have a plus in front of them if you subscribe to them and a minus in front of them if you haven't subscribed to them. But if you haven't subscribed to any events using an event object, these will just be 0 or an empty string if you access them. So now I mentioned event args briefly earlier. If you use the event object, you can actually access these event arguments. Every .NET event just defines just 2 arguments, sender and event args. Sender is going to be the handle to the .NET object that triggered the event, while event args is going to be different for each event. Effectively, event args is an object that was defined for the purpose of passing additional information to the event. And each .NET object in each event may define a different object type for event args. And you'll find that in the documentation for whatever .NET object you want to work with. Now, I've been using the button for pretty much all my examples so far, but the button doesn't have any good events that take advantage of event args to show it off. So for this example, I'm going to use the .NET month calendar .NET object with the date selected event for an example. So for the date selected event, the sender argument will be the month calendar.net object that the event triggered from, while event args will be of type date range event args. And this .NET object has just 2 properties, start and end. Each are of type datetime. So start is a datetime representing the first date in the range selected, and end is the end date in the range selected. So if you can imagine, you have got a calendar, you select a period, like you select 3 days in the month. The first day selected will be start, the last day selected will be end in that range. So here is an example of a simple object of handling, code for a object event handler. So in this case, the object definition is very simple. It's just defining one method, date selected, which has 2 arguments, our sender and event args. And then we have the syntax for event and the name of the event we want to subscribe to. So then it's pointing at the date selected label. So here's the actual code we want to run when date selected event is triggered. So we grab our 2 arguments. And then what we're going to do is we're going to access the start property of event args, which is a date time type. But that date time types in all .NET objects actually have a toString method. So what this will do is it will give me a string representation of the start date. And I can even specify it the date format I want to use. And I do the same for the end argument, so the end of our selection. So now I have 2 strings, one with a string representation of the start date of the selection and the end date. And then I'm just going to pop a message box displaying which dates were selected. The next thing I'm going to do is I'm going to access the end date again, and I'm going to use a method it provides called add months to return a new date time object that is 1 month after the last date selected. And then I can pass in that new date time object to the original, I'm going to access the original month calendar, and I'm going to set its date to the next month. So effectively, what we've done here is the user has selected the date in the calendar, it displays a message box of which dates were selected, and then it advances the calendar to the next month. So that is our object handler code. Now to actually use that, we instantiate our object, cal selection, and then we use on event from net calendar process date selected. And this will tell PxPlus that this object is used for event handling. So that is pretty much all the main content I want to go through. That covers what .NET is, what our PxPlus .NET interface can do, and sort of how to work with it. But I think the best way to sort of learn is by doing. So we wanted to use some more real world examples that sort of tied everything together now that we've explained all the individual bits. So we wanted to use a popular third-party .NET library for these examples. And we wanted to give you a bit more closer to real world examples that could be easier to sort of go off of and work off of from. And yeah, we wanted to sort of tie everything together at the end here of everything I just went over, because I can say lots and lots of words, but sometimes seeing is a lot faster to understanding. Now, for these examples, we're going to use the DevExpress.NET library. Now, this is a popular and powerful set of UI controls and processing tools. It's one of the industry standard tools. We've had several customers come to us specifically asking for support for DevExpress. It isn't a free tool set, but they do have a free trial. So you could easily get the free trial and run the example code we have here and try it yourself. So our first example is going to be using the DevExpress grid control. And what we're going to do is we're going to add a DevExpress grid to a panel. We are going to load that grid from an Excel file, and we're going to customize the grid's look a little. Things to note is this works and the grid loads very fast. And out of the box, the DevExpress grid gives us a lot of advanced sorting and filtering that you don't have to write or code yourself. So we're going to use nomads here, and we're going to click our external controls, and on our panel, we're going to draw a control that's pretty much our whole screen size. And then we're going to say it's a .NET control, and we're going to give it the path to our DevExpress grid DLL. Now, how I figured out which grid DLL to use, I just looked up in the DevExpress documentation, and in the documentation for the grid control, it says what the DLL is. It also says what your namespace and object name is. So that's where those came from. And I don't need any constructor arguments here, so that stays blank. Now, if I run that panel, I'm going to get an empty grid here. But I obviously didn't define any of this stuff, so it's just going to be an empty grid. But we want to load it with Excel data now. So I went online and I found a large Excel file. In this case, the data in it is air quality control data. It was just easily accessible large data source. So that's the one I went with. So it's called airquality.xlsx. So if I want to actually load my grid with it, I'm going to need to use a bit of code. So I'm going to define the default program called grid example. And in this grid example program, the first bit here, I'm actually just defining like the path where my DevExpress is installed. And then I'm defining the full path to the data access DLL. The data access DLL is the one that has the .NET objects defined for loading, creating a data source from Excel. All of this I got from the DevExpress documentation. I also found tutorials on, how to load grids from Excel, and it sort of walks through what to do here. But this one's actually a pretty simple example, so we should be able to walk through it quickly here. So we're going to do 3 objects. One is Excel data source, one is Excel worksheet settings, and one is Excel source options. So I'm first going to create a Excel data source object. Then this is just a data object, so you notice I don't need to specify a screen location. And then once I have this object, I can set the file name property. So this is where I'm telling, this is where I'm specifying what the Excel file is, where my data is. The next thing I need to do is I need to specify what worksheet I want to load data from in my Excel file. So this is where the Excel settings objects comes into play. Now this actually has a constructor argument that it needs, and it wants the name of the worksheet. So in this case, our worksheet was named air_quality. So that's what I pass in when I define my object. The last object I need here is the source options object. And it actually has a constructor argument where it wants the Excel settings object passed into it. So I pass into that Excel settings object I just created. And then I set one property here, use first row as header. Now what this will do is if I go back to our Excel sheet here, you notice my first row here is all the column names. So this is going to tell the system that you can grab all the column names from that first row. This is a Boolean type, so I just set it to 1, and that's setting it to true. So now I can pass in my Excel source options object to my Excel data source object, and the property it lives in is source options. And you notice here I've got $ on this side because I'm using PxHandle$ to do the assignment of the .NET object. And then finally, I can call the fill method of my Excel data source. What this does is it actually reads and pulls all that data and loads it into memory. And this, of course, I've put all under a label pre-display, so we can do it before we even actually draw anything on the screen, and everything can be nice and fast. So then in my panel definition, I can specify that during pre-display, I want to run that code I just defined. So now I can go into my external control properties for my .NET object. I can go to the Properties tab, and then I'm going to tell my grid object to use the data source I just created. And I can do this through the Properties grid here without writing actually any additional code. And I just pass it in my Excel data source variable, which I defined in the pre-display logic, passing it in as with tick PxHandle$, since it is a .NET object. The end result of that is if I run my panel again, it now automatically loads everything from my Excel file, including defining all the column names. I didn't have to write code to do that. And it has a bunch of advanced search features, advanced filtering, all the stuff built into the .NET object from DireXions. Now, maybe I decide that I don't like this bar up here, this drag a column header here to group by that column. This is on by default, but maybe I don't want them to be able to do that, or I want a cleaner look. So how do I go about modifying my grid? Well, in this case, since it's a sort of one line of code, I'm just going to go to the logic section for my .NET object. And then I'm going to say use the name of my object .ctl to and then tick, and then I'm going to access the main view object. And from that object, I access the options view object. And then from that object, there is a property called show group panel. And this is a Boolean property that defines whether that bar at the top is displayed. So I set it to 0 to false. Now main view and options view, these are child objects. That's why I can just chain everything together. And by changing them, I actually change the behavior of the parent. And how I figured out how to do that was all through the DireXions documentation. They have a pretty thorough documentation over there. So if I run my panel now, it's the same thing, but now I don't have that bar at the top. So it gave me control of that. So the last example I want to do is also DireXions, but the PDF viewer control. What we're going to do here is we're going to add a PDF viewer control to a PxPlus panel, but then we're going to move that control down a little bit, making it smaller within our WinForm. And then we're going to call a method that adds a ribbon bar above the PDF viewer control. And then we are going to load a PDF file, and then we are going to customize it a bit by disabling the ability to open links from a PDF file. The benefit of the DevExpress PDF viewer control is it's a fairly advanced embedded solution for displaying PDFs that may offer more features than just opening things up in a browser. So just like before, from Nomad's Designer, we can click our external controls and draw a rectangle as big as our screen, and then select .NET controls. And this time we're passing in the path to the DLL for our PDF viewer. And we're specifying the namespace and object name for our PDF viewer object. All that came from the DevExpress documentation. So if we run this, we now have an empty panel with an empty PDF viewer control, which just says this document does not contain any pages because we didn't load any PDFs. So, but we said first what we want to do was we want to move the PDF viewer control down a little bit to make room for a ribbon bar. So I'm going to modify the top property here. So this is the PVX top. This won't change the positioning of where the our external control is on the PxPlus panel. This will change the position of where the PDF viewer control is on that WinForm we have drawn on our screen. So I'm going to set it to 150. This is in pixels, so this is 150 pixels lower than the top of our external control. Now, I also now need to shrink the height a little bit, or else the bottom of the control won't be displayed. So I'm just going to use a simple expression here to set the height to be 150 pixels less than it currently is. So what that will look like is now I've got the same control here, but I've got this gray space at the top where I just see the WinForm, but nothing in it. But this is all a prelude, because now, since I'm just using a single line of code, I'm just going to use logic here and execute, and I can call the create ribbon method. And what this adds is this nice little ribbon bar that DevExpress has defined for PDF viewer controls that allows you to open PDFs, save PDFs, print, bind, all sorts of basic controls there. But we still haven't loaded an actual PDF, so we can use that using the load document method of the PDF viewer object. This method actually accepts one string argument, so we can do it right here from our grid. And all I have to do is pass in the name of the PDF I want to load. So when I load that, now I actually have my PDF all loaded in here. You'll also notice on the left here, it adds this, it's got this built-in bar where you can access comments, bookmarks, attachments, things like that within the PDF. So if I scroll down to the bottom of this sample PDF, there is some hyperlinks. And if I click on the hyperlinks, I notice I get this security warning pop-up. This is all the default behavior of the DevExpress control. And it asks me, is it okay to go outside and connect to the internet and open that link? And you can say no or yes. But say we don't like that behavior. We want to display our own message, or in our case, we don't want them to be able to open links at all. We just want them to get an error message if they try. So how do we do that? Well, we can do that via events. I'm going to create a simple event handler object, and I'm subscribing to one event, URI opening. So this event is triggered whenever the PDF viewer has a click on a link to open a link. I'm just using the same two .NET arguments that are true for all .NET events, sender and event args. And then I'm going to access the handled property. This is a Boolean property that if set to false, the default behavior is maintained of the PDF viewer, which would bring up that security warning message box and then allow them to go or not go into the link. So I want to set this to true to say that I'm going to handle this event click, and it should not bring up that message box itself. I'm going to bring up my own message box here, just saying that it is not allowed. And then I'm going to set another property here called cancel, which is also a Boolean, to true, to say don't actually open the link. If this is false, it will actually open the link. So then now that I have defined that object, I have to instantiate that object and use it to subscribe to events. So I'm just going to instantiate it here using new, and then I'm going to use on event and pass in that object. And I added that all just before the create ribbon method I already called. So the end result of that would be now when I load my panel and click on one of those links, I just get an opening links not allowed, and it never actually opens the link for me. So that pretty much covers everything we want to go over. We have a lot of other resources about our .NET interface, several how-to tutorials on working with .NET interface. We've got a 2-part video series on YouTube. There's several pages that go into all the details we covered here in our help and manual. I've also got a link here for the .NET API browser from Microsoft. This is a way to go through and look at all the different system objects that are defined by the system. So when we were doing the button object and the calendar object, those are all system objects, and you can find information about them or what other objects there are through the .NET API browser. So I'd like to thank you, everyone, for coming here and listening. Now we should have plenty of time for questions, hopefully. I don't see any hands up, so
James, James, you can ask your question.
Yeah, it's actually something that is also landed in the chat, and they expressed it a little bit more clearly than I did. It says here, I noticed the .NET DLL name in Nomads was a fully qualified path, and this implies that DLL will always be installed in the same location on all Windex workstations. Is that realistic, and is there a way to use an expression instead?
Okay, so you're talking about when defining the DLL name in Nomads.
Correct.
And it is it could either be the name of the system DLL or the path to the third-party DLL. I trying to think if there's a way to make that a expression at that point.
Because DLLs do get updated from time to time, and if there's a change, then you'd have to go back and update everything.
Yeah, I'm not 100% sure on that. I can get back to you on that. I did more the back end work, not the Nomads interface. So I feel like it's possible we may already support that, but if not, it's something we can certainly look at, making sure it would support if you put in a variable name.
Yeah, put in some sort of expression compatible.
Yeah.
And that's all I've got. Thank you.
Jeff, you can.
Yeah. Hi, Devin. I noticed earlier in the calendar example that you had, you created a new object for the next month and then passed that back in, but you never dropped that. Was that just an oversight, or is that something that wasn't necessary?
Let me go back here to the.
So I'm just curious.
So is the calendar.
How we know? Is there a good way to know?
Oh yeah.
When we have to drop an object and when we don't.
So this is the calendar one.
So that NXT MNT, should that be dropped?
Oh, next month. Add months set. Yeah, that probably should be dropped in if you wanted a complete example. I was trying to, and as much as I could, I tried to make sure all the drops were there, but I also wanted things to fit on one screen. And this was already getting busy. But yes, date time object would be a value type object. So you would want to actually delete next month there. Because once you pass it in, you're done with it.
Is there a good trick for us to know when that needs to occur? Is there something we can expect, or
it's in the documentation for whatever object you're looking at. It would usually tell you if it's sort of a value type or not. If it doesn't say anything, it's probably not value type, but usually it's value type, it'll tell you. Because then, yeah, whether you're working directly in like C# and .NET or PxPlus and .NET, it's going to be the same thing. You gotta,
okay.
well,
Is there
within
anything?
C# directly, there's like a automatic garbage collector.
Yeah.
Which,
is there anything in the language that gives us ability to know if we've left something open, or something like the TCV39 for native objects, or?
not currently. So we could certainly probably look at adding something like that because that information would be available that we could probably return. Like the number of sort of current .NET objects you have still active on the system.
So one of the things, the reason I ask is one of the examples I was thinking of is that we often try to, for some of our native objects, we try to create some test code that tests the objects. And one of the things that always double checks is that the number of objects open before the test runs and then after the test is complete and the object is dropped is equal. So we're sure that we didn't leave any objects or files open.
Yeah.
Is there something similar that we could know for these
Well,
types of programs so that we
these
know
objects, yeah, these objects would be treated as any other PxPlus object. So the numbers would go up on the number of PxPlus objects when you instantiate one of these and go down when you clean them up.
Oh, okay.
So
maybe can, that would be.
You can probably, if you don't need to have like a differentiate, like I want a number of only how many .NET objects I have versus how many objects in total. Like we have how many objects in total we have currently. But we don't have anything that just tells you how many .NET objects you have. Although we could do that if that would be helpful. But maybe
that would work.
Yeah,
because what I do is I check TCV39 and then I run my test code and then check it again to make sure that the number came back down and we didn't leave anything open. Yeah. Okay.
And the way we implement the system as much as possible is we clean up things for you. So yeah, like if you are doing things like event args, tick end, tick add months, you didn't have to drop the end object. Sort of it handles it. It knows the context of that when it can drop objects in the middle for you like that. It's only the value objects where that becomes a bit tricky because it's a copy. But for the most part, it's fairly straightforward. And if you're if you're returning something like a date time type, then yeah, you want to make sure you clean that up.
Okay, thank you.
Okay, let's look at some of the questions here. If anyone has okay, I see someone, Jose Rivas, all UI libraries are for paid or exist any library for free use. There is both. With over 300,000 different .NET libraries out there, there is a lot of open source or free to use libraries, and there is a whole lot of paid for libraries. From anywhere from tiny little companies to big giant companies like DevExpress. So you have all those options. WinForm objects are built into the OS and are free. Oh yeah, that's someone else answering. Yes, all the system objects are built in and are free. we did do some examples with PDF viewer and grids. Yes, and we do have how-to tutorials. We have one specific for the calendar too, whether you're using nomads or non-nomads.
I have one more question, if you got a moment.
Oh, sure.
So for the non-UI .NET libraries and DLLs, are those, how do we access those? Is it on the server side when in a Windex environment? Is it always on the server? Do we specify that using the Windex tag if we want it client or server? And do those work on Linux as the server?
Well, right now, how our .NET support works is it is through Windows. It is like they're sort of .NET has evolved over the years where there was just .NET Framework, which was Windows only, and then there's now there's .NET Core, which is sort of the more open source multi-platform one. We're sort of just targeting .NET, which is on the Windows only side currently. So what that means is if it's not graphical, but your server is Windows, then it could be on the client or the server, and you control that via WDX or LCL in front of your square bracket .NET. But if your server is Linux, then you would need to make sure to run that on the client side. We do have plans to look into if we can expand our support to the sort of the more open source multi-platform variants as well. Obviously that would only be for the non-graphical ones. But most people who are asking for this seem to be interested in a lot of the graphical stuff. So that was our first sort of what we wanted to make sure we got working first.
Thank you.
I think there's another hand up, Ross McKenzie. Oh, but they're still muted.
Ross, just unmute yourself.
Sorry, I clicked on the wrong button.
Oh, no problems. We still have time. Muted again. Okay. I don't see any more questions. Well, someone asked how DevExpress controls can be used. We had two examples at the end here of how to use DevExpress controls. And like all these presentations, we're going to be providing you with the slides. Everything will be on the knowledge base, so you'll be able to go through those on your own time and be able to copy and paste and play around with them. So Ross is